James Webb just saw something impossible on Pluto. Scientists are stunned. In June of 2025, something happened that made every scientist studying Pluto hold their breath. After decades of speculation and failed attempts with inferior instruments, the James Webb Space Telescope finally did what many thought was impossible. It locked onto Pluto's faint infrared signature and confirmed a hypothesis so controversial that when it was first proposed back in 2017, real scientists actually laughed about it. And now, as the data poured in from millions of miles away, those same scientists who doubted found themselves scrambling to understand what they were seeing. Because Pluto wasn't supposed to be this active. It wasn't supposed to be this strange. And it definitely wasn't supposed to be doing something that defies everything we thought we knew about planetary climate. The dwarf planet, 4 billion miles from Earth, was actively cooling itself down, using nothing but the haze floating in its own sky, and nobody had fully proven it until now. This is the story of how a little world that got kicked out of the Planet Club turned around and shocked every single astronomer watching. When Clyde Tombaugh discovered Pluto on February 18, 1930, sitting in that small observatory in Flagstaff, Arizona, comparing photographs night after night, he had no idea he was looking at something that would eventually overturn more than 7 decades of planetary orthodoxy. For 76 years, Pluto sat confidently as the 9th planet in every textbook, every planetarium show, and every science classroom across the world. Children grew up learning its name alongside Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. It was small, yes, but it was official. It belonged. Then in 2006, everything changed. A group of astronomers gathered together and voted on new rules for what qualified as a planet. Pluto failed to meet the criteria. It was reclassified as a dwarf planet in what felt like an astronomical tragedy to millions of people worldwide. Kids who had grown up with Pluto as the 9th planet suddenly had to rewrite their understanding of the solar system. The little world had been expelled from the club. It had been deemed unworthy. But that single decision, that one moment of planetary demotion, was actually the beginning of the strangest scientific discovery about any world in our entire solar system. For most of the 20th century, scientists knew almost nothing about Pluto. Through the most powerful telescopes available on Earth, it appeared as nothing more than a fuzzy, indistinct smudge of light. Researchers couldn't determine its true size. They couldn't see its surface features. They had no way of knowing whether it possessed an atmosphere or if it was just a dead, lifeless ball of frozen rock. Everything humanity thought it understood about Pluto was essentially an educated guess built on top of another educated guess. The distance was staggering to contemplate. If Earth were the size of a basketball, Pluto would be smaller than a golf ball, floating roughly 40 times farther from the sun than our planet. The sunlight that reaches Pluto is so incredibly faint that standing directly in Pluto's daytime would feel like deep twilight on Earth, even when facing the sun directly. The temperatures there are almost incomprehensibly extreme. The surface hovers around 380 degrees below 0 Fahrenheit, more than 250 degrees colder than the coldest temperature ever recorded anywhere on our entire planet. At such extreme cold, nitrogen, the very gas that makes up most of the air we breathe, freezes into solid rock. Everyone expected Pluto to be extraordinarily cold. That wasn't the surprise. Scientists had predicted that thoroughly. The real shock came when observations began revealing that Pluto was even colder than their mathematical models had calculated. Something out there in the darkness was making it chillier than planetary physics suggested it should be. For years, nobody could explain what was causing this anomaly. There was no spacecraft close enough to study it properly. Earth-based telescopes were simply too primitive to see the details scientists needed. The mystery persisted, unsolved and puzzling, until July 14, 2015, when everything changed forever. After traveling through space for nearly a decade, covering an inconceivable distance of 3 billion miles, a small spacecraft called New Horizons finally reached Pluto. It had just one chance to complete its mission. There would be no second pass, no returning for another look, no slowing down to take a closer inspection. The spacecraft rocketed past Pluto at more than 30,000 miles per hour, with just a few precious minutes to capture everything it possibly could before disappearing into the eternal darkness beyond. The images and data that came streaming back completely shattered what scientists thought they understood about this distant world. Right in the middle of Pluto's surface was a massive pale patch shaped almost perfectly like a heart. It was remarkably smooth and strangely youthful compared to the ancient, heavily cratered terrain surrounding it. Nearby, mountains made of solid water ice towered more than 10,000 feet into the thin sky. At Pluto's freezing temperatures, water ice doesn't behave like the slippery substance we know on Earth. Instead, it becomes hard as rock, so dense that striking it with an object would produce a ringing sound, almost like metal. But the feature that truly shocked every scientist examining the New Horizons images was something unexpected floating above Pluto's surface. Layer upon layer of soft blue haze rose hundreds of miles into the sky. When sunlight hit this haze from behind, it actually glowed. Nobody had predicted that a supposedly dead, cold, frozen world only slightly larger than our moon would possess anything like a substantial atmosphere hanging in its sky. The data showed that Pluto had weather. It had an atmosphere. The question that consumed every researcher was whether this haze was merely a beautiful visual curiosity, or whether it was somehow connected to the mystery of why Pluto felt colder than the equations suggested it should be. New Horizons couldn't answer those questions. It had gotten its single glimpse, then continued flying deeper into the darkness, traveling farther into the void where it could never return. The secrets of that haze would remain hidden unless scientists found a completely revolutionary new way to study them from across the solar system. What astronomers desperately needed wasn't another photograph. Pictures alone couldn't reveal what the haze was composed of or what it was doing to the surrounding atmosphere. They needed an instrument that could read Pluto's sky from millions of miles away without ever sending another spacecraft anywhere near it. Incredibly, that instrument did exist, though it hadn't been fully operational when New Horizons flew past Pluto. The James Webb Space Telescope, humanity's most powerful infrared observatory ever built, was just coming online, undergoing its final calibration phases. When the JWST finally turned its revolutionary attention toward that distant, heart-shaped world, absolutely everything scientists believed they understood about Pluto's atmosphere was about to get turned completely upside down. The James Webb Space Telescope works in a completely different way than traditional cameras flying past planets at high speed. Instead of simply taking photographs, Webb reads light itself. It breaks light apart the way a prism splits sunlight into a rainbow, using that spectrum to determine exactly what something is composed of. It performs this entire analysis without ever leaving Earth's orbital neighborhood. Think of it like being able to tell what someone ate for breakfast, just by analyzing their breath from across a room. That's essentially what Webb does, except instead of analyzing breath, it's reading tiny particles of light that have bounced off a world 4 billion miles away. The challenge was enormous. Pluto and its largest moon, Charon, orbit so closely together in our sky that separating their individual light signatures was nearly impossible with older equipment. It would be like trying to hear one friend whispering while standing directly next to someone shouting at the top of their lungs. Scientists had attempted for years to catch a clear signal from Pluto's haze alone, but they kept failing because Charon's overwhelming brightness kept drowning out Pluto's fainter signature. Then, in 2022, Webb's instruments finally achieved enough precision to pull those two signals apart separately. For the first time in human history, scientists could study Pluto completely in isolation from its moon. What they discovered confirmed something that one courageous scientist named Xi Zhang had proposed back in 2017, back when almost nobody believed him. Back then, the idea had seemed almost backwards. Everyone knew that hazy atmospheres typically work like blankets, trapping heat close to the ground like a greenhouse. Xi Jinping proposed something revolutionary and counterintuitive. He believed Pluto's haze was doing the exact opposite. He theorized that it was absorbing the faint sunlight streaming in during the day and then throwing that heat straight back out into space as fast as possible, faster than Pluto's thin atmosphere could ever retain it. In other words, instead of functioning like a blanket trapping warmth, the haze would work like a tiny radiator, quietly bleeding heat away from a world that barely had any warmth to spare in the first place. When Zhang first proposed this idea, many in the scientific community thought he was overreaching. There was simply no way to test such a hypothesis at that time. That fundamental roadblock changed in June of 2025 when a research team led by a scientist named Tanguy Bertrand used Webb's unprecedented infrared capabilities to measure Pluto's sky with unprecedented accuracy and detail. The results, published in the journal Nature Astronomy that same month, matched Zhang's hypothesis almost exactly. Pluto's upper atmosphere really was being actively cooled by the haze circulating within it. The measurements revealed that Pluto's atmosphere was approximately 30 degrees colder than older climate models had predicted. Think about what that means. Pluto isn't simply cold because it's inconceivably far from the sun. In a very real and measurable sense, this distant world is actively refrigerating itself, using nothing but the haze suspended in its own sky. It's running its own private refrigerator unit, powered entirely by physics and chemistry. Scientists are now calling it a completely new kind of climate phenomenon, one that doesn't match anything else astronomers have ever studied anywhere in the entire solar system. This discovery opened up an entirely new set of questions. If a tiny world as distant as Pluto can quietly chill its own sky using nothing but haze, what other strange worlds might be doing similar things out there in the darkness without anyone noticing yet? What other planets or moons might possess these exotic climate systems that we haven't discovered yet? But the haze floating above Pluto turned out to be hiding one more extraordinary secret, one that leads straight into one of the strangest relationships between any two worlds scientists have ever discovered anywhere in the cosmos. Pluto has been slowly leaking into space for billions and billions of years. Gas from its thin atmosphere drifts slowly upward, escapes Pluto's weak gravitational pull, and floats off into the vacuum. Scientists already knew this escape was happening, and what they didn't understand for a very long time was where all that escaping gas was actually going. It turned out it wasn't simply disappearing into the void. Something was catching it. Pluto's biggest moon, a battered ice world called Charon, orbits so incredibly close to Pluto that the two bodies are locked together in a strange kind of cosmic dance. Charon is massive relative to Pluto compared to other planet-moon systems. Most of Charon's surface looks like ordinary water ice, cratered and gray, except at its poles. Both of Charon's poles are stained a distinctive, unmistakable deep reddish brown, darker than anything else visible anywhere on the entire moon. For years, astronomers suspected that color was somehow connected to Pluto, but they simply couldn't prove it. The explanation finally came together when researchers understood Charon's unusual orbital tilt. Because of the way Charon is tilted as it circles Pluto, its north pole spends decades sitting in complete total darkness at a time. No sunlight reaches it whatsoever during that extended stretch. That dark frozen pole becomes an incredibly effective trap for cold gas escaping from Pluto. Bits of Pluto's atmosphere drift over the vast distance between them, freeze solid instantly onto that dark, frozen pole, and simply accumulate there for years, waiting. When sunlight finally returns to that region of the moon after decades of darkness, something remarkable and strange happens. The frozen gas doesn't simply melt away like anyone would expect. Instead, powerful sunlight and intense cosmic rays smash the frozen gas molecules apart and recombine the leftover pieces into much heavier reddish-brown compounds. This new reddish material doesn't evaporate back into space. It stays locked onto the moon's surface permanently, deepening that dark stain slightly more with every single cycle. Two separate worlds, one giving away pieces of its sky, the other quietly catching and transforming it into permanent color, have been locked in this slow exchange for longer than either one has even had a name. This is a relationship between two worlds that exist nowhere else in the entire solar system. The observations published in April and June of 2025 revealed that Charon has even more complexity than anyone suspected. Researchers using Webb's enhanced infrared vision discovered something that had never been confirmed on Charon's surface before. Frozen onto the moon's dark poles is a mixture of carbon dioxide, the very same gas leaving your lungs with every breath you take, and hydrogen peroxide, the same substance sometimes used to disinfect cuts. The carbon dioxide likely came from material buried deep underground that was dug up and scattered across the surface by ancient asteroid impacts. The hydrogen peroxide seems to have formed slowly over billions of years as radiation kept striking Charon's water ice, rearranging it into something entirely new and unexpected. Just when scientists thought they had Charon figured out as a plain, boring ice ball covered in craters, it turned out to be far more chemically complex and interesting than anyone had previously imagined. By this point, here's what scientists actually know for certain. Pluto is actively cooling its own sky using suspended haze. That same haze is slowly leaking away, drifting onto its moon and painting that moon's poles a deep, permanent red. Two frozen worlds locked together in an orbital embrace, quietly trading pieces of themselves back and forth in a cosmic exchange for billions of years. But Pluto still had one more layer of mystery buried beneath all of that surface complexity. And this next piece might be the strangest and most mind-bending part of the entire story. When New Horizons zoomed past Pluto and examined its surface in detail, it photographed something that nobody had ever seen anywhere else in the entire solar system before. In a region that scientists named Tartarus Dorsa, tall, jagged blades of ice rise up in long, repetitive rows, with some reaching more than 1,500 feet high. All of these towering ice formations are made of frozen methane. Similar, much smaller versions of these ice blades actually exist here on Earth in certain high mountain deserts where they rarely grow taller than an average person. On Pluto, that same basic physical process seems to have played out on an absolutely massive scale over an extraordinarily longer stretch of time. Research published in 2025 that re-examined New Horizons data suggests these giant ice blades might wrap around as much as 60% of Pluto's entire equator, like a jagged, frozen ring of teeth circling the whole little world. Not far from Pluto's famous heart-shaped region, there are two enormous isolated mountains that still baffle scientists. One rises approximately 13,000 feet high. The other might reach nearly 20,000 feet, wide enough at its base to rival some of the biggest volcanoes here on Earth. Both mountains have deep indentations at their peaks, surrounded by cracks with lumpy, irregular sides that look almost exactly like cooled lava flows, except there's no melted rock on Pluto. There can't be, given the extreme cold. If these mountains really are what they appear to be, they're ice volcanoes, ancient geological features that once pushed up a thick, slushy mixture of water, ammonia, and methane from somewhere deep beneath Pluto's frozen outer shell. And that raises the most profound question hanging over this entire mystery. If something down there was warm enough to push liquid material all the way up through miles and miles of solid ice, what if that warmth is still down there right now? Scientists increasingly think it's actually possible that Pluto is hiding a liquid ocean of water buried approximately 100 miles beneath its icy crust. This underground ocean would be kept from freezing solid by residual heat still leaking out from Pluto's rocky core. It's not a photograph proving this exists. It's a pattern. Cracks across Pluto's surface line up in exactly the way geologists would expect if a thick layer of liquid water were slowly shifting underneath all that ice. And that same heart-shaped region sits directly above a spot where something denser than the surrounding ice seems to be pressing down from below, almost like a heavy weight sitting beneath the surface. If that hidden ocean truly exists down there, it's been sealed away from sunlight for billions of years, sitting in absolute, total darkness under crushing pressure, fed only occasionally by material seeping down through cracks above it. That would make it one of the strangest possible places in the entire solar system where the basic chemical ingredients for life might exist. It would be life's ultimate extreme environment, cut off completely from any star at all, isolated in a way that almost defies imagination. It would be an entire ocean world, complete and closed off, existing in eternal night. There's one more piece to this puzzle that ties everything together in a profound way. Even the faint trickle of sunlight that reaches Pluto is enough to break apart methane gas high in its atmosphere. Those broken pieces of methane molecules don't simply disappear. They slowly rebuild themselves into heavier reddish-brown particles that drift down through the atmosphere and settle onto Pluto's frozen surface. That same kind of material is part of a group of molecules that some scientists believe may have once rained down onto early Earth. Those early Earth rains of complex organic compounds possibly helped supply the raw ingredients that life eventually grew from. On Pluto, that exact same process has been happening quietly and steadily for roughly 4 billion years. A slow, steady snowfall of the building blocks of life, falling forever onto a world that's simply too frozen for any of it to ever spark into something alive. It's the saddest irony imaginable. Pluto is literally being rained on by the chemical precursors of life, yet the world is too cold for anything to ever develop. Here's where all of this leaves us. Pluto was never really the dead, boring end that everyone assumed when it lost its planet title back in 2006. It turned out to be the beginning of a whole new set of questions about how planets and moons actually work. It sits inside a massive, mostly unexplored region called the Kuiper Belt, home to hundreds of thousands of icy worlds that astronomers have barely even glanced at. If one small, frozen, previously dismissed dwarf planet was hiding all of this incredible complexity, a self-cooling atmospheric system, a moon quietly stealing its air, possible ice volcanoes, and maybe even a hidden subsurface ocean, it's worth wondering what else might be sitting out there in the darkness, waiting for humanity to finally take a much closer look. The James Webb Space Telescope has fundamentally changed how scientists think about distant worlds. It's shown us that Pluto isn't the barren, lifeless place we once assumed. It's revealed a complex system of interactions, chemistry, and geology that rivals anything we've studied in the solar system. And it's raised the most profound questions. If Pluto can be this strange, this active, this chemically rich, then what are the thousands of other icy worlds in the Kuiper Belt actually doing out there? What other impossible things are happening billions of miles away that we simply haven't discovered yet? What other hidden oceans might exist beneath frozen surfaces? The universe has shown us that it's far more creative and surprising than our theories suggested. The story of Pluto is a reminder that science works best when we remain humble about what we think we know. Xizang held onto a controversial idea for years when almost everyone dismissed it. He waited for the technology to catch up to his hypothesis. And when Webb finally came online, when its instruments became sharp enough to pierce through the darkness, the truth emerged exactly as he predicted. That's the real power of scientific inquiry. The willingness to ask crazy questions, to entertain seemingly impossible ideas, and to have the patience to wait for the technology and observations that will eventually prove them right. Every time humanity looks deeper into space, using better instruments and more sophisticated methods, we discover that the universe is stranger than we imagined. Pluto taught us that lesson brilliantly. It taught us that the smallest worlds can hold the biggest secrets, that the coldest places can host the most complex chemistry, that a little dwarf planet that got voted out of the planetary club could turn around and astonish everyone who ever doubted it. What makes these discoveries even more significant is how they reshape our understanding of extreme environments. Scientists are now asking whether Pluto's unique climate system might exist on other distant worlds. The JWST is surveying other icy Kuiper Belt bodies for similar patterns. If more worlds possess this self-cooling capability, it could fundamentally change how planetary scientists classify distant systems. The implications extend beyond our solar system. When astronomers study exoplanets, they're wondering whether some might possess similar haze-based climates. Pluto's discovery has given researchers a new interpretive tool for analyzing distant worlds. Xizhang, the scientist whose 2017 hypothesis was vindicated by Webb's observations, has described the confirmation as one of the most satisfying moments of his career. After years of defending an idea that many dismissed as impossible, seeing it proven correct must have felt profoundly surreal. His work demonstrates the tremendous value of theoretical prediction and the crucial importance of patience in scientific endeavor. Sometimes, the most important discoveries don't come from observing something entirely new. They come from finally having the instruments precise enough to prove what someone already predicted through rigorous theoretical work. The James Webb Space Telescope itself has become almost legendary in its accomplishments. Launched on December 25, 2021, after years of delays and development challenges, it was designed to look deeper into space and time than any telescope before it. Its infrared capabilities allow it to see through cosmic dust and detect the faint heat signatures of objects billions of miles away. What started as a tool primarily designed to study the early universe and distant galaxies has proven invaluable for studying our own solar system in unprecedented detail. The future of Pluto research is wide open. The scientific community is actively discussing the feasibility of sending an orbital mission to Pluto to study these phenomena even more closely. Such a mission would be incredibly challenging, requiring either decades of travel time or revolutionary propulsion technology to reduce the journey duration. Yet the discoveries made so far have made such a mission seem increasingly worthwhile. An orbiter around Pluto could analyze the atmosphere composition directly, sample the surface ice, and potentially search for signs of subsurface ocean water. If scientists do eventually send a mission to Pluto, they'll be looking for several specific things. They'll want to directly measure the atmospheric composition and temperature profiles to confirm the self-cooling mechanism. They'll want to study the ice volcanoes and attempt to determine whether they're active or merely ancient features. They'll want to examine Charon up close and understand the exact mechanism by which atmospheric escape and surface chemistry are linked. And if it's possible to detect a subsurface ocean, they'll want to search for it with seismic or magnetic instruments. The discovery also has profound implications for astrobiology and our understanding of life's potential distribution throughout the cosmos. If Pluto's hidden ocean exists beneath its icy crust, it could theoretically harbor microbial life, even without any sunlight whatsoever. On Earth, we know that bacteria thrive in deep-sea hydrothermal vents, deriving their energy not from sunlight, but from chemical reactions occurring in superheated water. Pluto's hidden ocean, if warm enough from the dwarf planet's residual internal heat, could theoretically support similar chemically powered life forms. That would fundamentally mean life could exist in far more places than we previously imagined possible, dramatically expanding the potential habitable universe. The study of Pluto's chemical complexity has also opened doors for understanding how complex organic molecules form in extreme environments. The particles falling onto Pluto's surface from atmospheric breakdown are the same types of molecules that may have been key to life's origin on Earth. Understanding how they form and accumulate on Pluto could provide insights into chemical pathways that led to life's emergence billions of years ago. The next time someone tells you that astronomy is settled, that we understand how planets work, that there are no more surprises waiting in the depths of space, remember Pluto. Remember that frozen little world 4 billion miles away, quietly cooling itself down, trading its atmosphere with its moon, preserving the building blocks of life on its surface, and possibly harboring a hidden ocean in the dark. Remember that science is a continuous journey of discovery, that yesterday's impossible becomes today's confirmed fact, and that the universe will always find ways to astonish us if we keep looking hard enough.